Okay, so let's see, where did we leave off, right? So what did you guys find out? What is about cotangent? You can start putting your answers on the, about cotangent on the chat. If you have the work done, you can upload your file if you wish, picture or something, right? So yesterday and the day before, we talked about these interesting features about cotangent. Oh, did I leave out something here? 175%. I might have that. I might have a typo here. Okay, just notice. Yeah, no, there's no typo. It just doesn't. It's not visible when the font is not large enough, right? So we observe these tangent, right? We did all these groundwork to make sure we understand what's going on, and then how is that being translated into mathematical notation and to express that dynamic process, to express that dynamic process, okay? So in your calculus classes, you're going to be dealing with all kinds of dynamic processes, which limit continuity. You have to use your imagination to do that, right? And based on the algebra. And we also worked out the intercept, the x-intercept, the y-intercept, right? We have the y-intercept, and but we also have the cotangent, right? Cotangent will have something similar too. Cotangent will have something similar too, but cotangent is different. Okay, it's defined differently, right? Because a cotangent is going to be the red number over the blue number. Will be the red number, blue number. Okay, so just for your information, tomorrow I will be teaching the other pre-calculus class, and in that class, but because today's lecture and tomorrow's your lecture is going to be just the lesson, it's just 1 hour and 35 minutes. But in the other lecture, I might go over what lead us to the unit circle. Okay, so for those of you who have never taken, this class, who has never taken trigonometry, okay, you might find this unit circle bewildering. Okay, so I might spend some time on that, and I will record it and make it available to you as I was teaching the other class. Okay, so let me know if you want to see that. And I'm not sure we have time to do this in both classes. If we can resolve it by just having the recording for you, and we will do that. We will do that. Unless, after you watch the recording, you have questions, I'll take your questions, okay? So I'm trying to take care of everybody, but you must put in the effort. You must put in the effort, okay? I just had a conversation with a student, with a colleague. She teaches pre-calculus and the calculus classes during the pandemics. And, she said, she caught a, cheating. That cheating turnout started in Math 170 from trigonometry, and all the way up to eventually, that student was caught in calculus, right? So the student was able to manage by cheating 170, 180, and then caught in Math 190. And it is so sad that should happen. But we also understand, our human nature and our resourcefulness could get to the wrong way. But if you don't put in the effort and you want to harvest, and then one way or the other, that person will be caught up somewhere, and which is going to result, it's not going to look very pretty. It's not going to look very pretty. And so I just want to tell you guys that I assume everyone is innocent until, you know, proved guilty. And personally, I assume everybody wants to learn this and really want to, you know, make the effort to learn this. And so with that kind of spirit, I would try to touch, you know, I would try to accommodate everybody's learning need, because you guys are from such diversified backgrounds. And some of you have never taken trigonometry, which is a big gap over there. But if you put in a lot of effort, that gap may be mended, but it cannot be done by cheating. It cannot be done by cheating. Okay, so it just somewhere down the road, and that person is going to be caught, and it's going to end very badly. Okay, but anyway, without further ado, I will have that recording about the making of this unit circle, okay, from the definition. So let's come back to our cotangent study, right? We know this is a cotangent curve, right? We just need to have that patience, right? And I'm trying to see that maybe we can spend a little less time to do this, but it should not compromise that process, because there's so much time, there's so much work is needed behind or after the classes that's demanded of you as a student. And you know, I was a student before, you know, and you are the student now. I can totally understand your situation. You have to, you know, to learn all of this, but there's no shortcut, the so-called shortcut. Okay, you just have to put in the work. Okay, so without further ado, that this of course is a cotangent. For cotangent, we need to be aware of the domain, and we already know the domain. We talk about the domain, right? We talked about the domain. The domain is that it cannot be k pi. It cannot be k pi. In a similar nature, that you can see that these are the numbers it cannot be, right? It cannot be 0. It cannot be pi. It cannot be negative pi. It cannot be multiples of pi, right? And therefore, there will be these vertical asymptote, very similar to tangent, very similar tangent. But these pieces of curve, on each piece, it is decreasing. It's a decreasing function, okay? And how it works. So you just have to have the patience to work it through. And I would try to speed up a little bit here, because we cannot afford to do that great details as we did tangent. Okay, so without further ado, so you would like to plot the point, but because by definition, right? By definition, we know that cotangent, right? Cotangent of an angle, right, in the domain is a cosine of A divided by sine of A. Okay, so of course we have talked about, you know, denominator cannot be 0, therefore it cannot be k pi. So now we know that A can be any real number but k pi, multiples of pi. K cannot be multiples of pi. Okay, so with that said, right, we can pick points. Right? So determine the two, you can see there's a one-to-one correspondence between, you know, between the making of the curve, of the cotangent curve, and the unit circle, So we would identify the terminals that cannot be, right? I'm actually using the red, even though this red should be separated from the red number. Okay, I realize we should use red because I just learned in sports, red card means what? Red card means what? Farouz, tell us. Red card means what?
You are out.
You're out. Okay. So these terminals are out when we work with the cotangent. Okay, they're different from the red numbers. Okay, they're different. They're totally different things. Okay, but the red terminal says these terminals are out. Any angle ends on these terminals, they cannot be in the domain of cotangent. That's what it's saying. Okay, so I decided to use the red. But in terms of the making of the ratio for cotangent, it's going to be the red number, which is for cosine, divided by the blue number. The red number divided by the blue. Okay, the red number divided by blue. So when we use the red number divided by blue, right, what will happen? So you will make up another table. You make up another table, okay? So how about you guys work with me? And I'm gonna create the table for you, right? I'm gonna create the table for you. And if we need breakout rooms, then we will do it. We will do it. The breakout rooms, if we need it, right? So we're gonna pick some numbers. Obviously, that there's the two terminals are out, right? The two terminals are out. We're gonna choose terminal from. We're gonna choose some special angles, right? Let's do some special angles. So I'm going to do pi over 6. Okay, pi over 6. These special angles are in service to us. Okay, the important thing about these special angles is they're easier to use. They're easier to use. And then you do the cotangent. Then you do the cotangent. Okay, cotangent of these angles. Right, and you make up the points. When it comes to these details, okay, most of the teachers don't teach this. They expect the student to know. They expect the student to do it. You guys with me? So you're a professor in calculus classes where you're in trigonometry classes. Even you have taken trigonometry, I doubt you have done this. Okay? Give me some feedback. Did you, when you did trigonometry, did you do this? Did your professor did this in class?
No.
Most likely not. There's no time, but it's expected of you to have done it. Do you guys understand? Okay, that's the nature of academics. Your professor probably do example 1, 2, 3, and you're expected to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. Since when we graph this kind of function, we always do pi over 6 as the input. So when we graph these kind of function, we always do, why do we do this? Yeah, we see a question. So when we graph these kinds of functions, we always do pi over 6, pi over 4, pi over 3. Are you asking why? You certainly don't have to. You don't have to. You can do 20 degrees, 40 degrees, 70 degrees, 80 degrees. You can do that. And just convert them to radians, and you are going to get the same curve. You are going to get the same curve. You're going to see the same insight. The reason we use these special angles is because it's a bit easier. It makes the process easier. It's not because these angles are any importance. In terms of practicality, okay, in real life, you're not going to see these angles most of the time. If you handle similar situation, you probably will have a 20 degree. You may have a 75 degree. You might have an 80 degree, 86 degree, things like that. But they can all be handled in the same way. They can all be handled in the same way. You guys follow me? The reason we use these special angles is because they offer some simplicity in the process. That's all. So they are in service to ARD. These special angles are in service to ARD. So let me type that. Special angles are in service to ARD. Let me tell you, I have students who come to my classes, doesn't matter, calculus, pre-cal, right? They come in with that unit circle, right? They remember every point. But when you ask them a question, they don't know how to answer. If I ask them a question out of the box, meaning other than the unit circle, other than the special angle, or I wanted to have few turns, okay, counterclockwise or clockwise, they have no idea. They will not know the answer. What does that mean? That student did not understand trigonometry at all. What is the core of trigonometry? ARD. So the special angles is in service. Special angles are in service to understand ARD. Do you guys understand the relationship? Okay. You can see how much we have digged out of these from definition using the special angle, right? But anyway, so in your academic career, you will see most professors using these special angles. Why? They're much easier to manage. And also they give you the precise answer. They give you the precise value. Okay, you get √3/3, √2/2, and √3, even though these numbers are not as neat as 1, 2, 3, but that's the best you can do. We just want to keep it simple, but what your professor is really assessing is you really understand ARD. It may or may not be clearly spelled out because they might spend a lot of time explaining how these, how to use these special angles, but don't lose sight. Don't lose sight. Okay, the 3 pillars of trigonometry is ARD. That's it. Okay, all the question you deal with is either from A to D or D to A. Okay, just read my lips. Read my lips. Okay, so with that said and done, so how would you analyze this? Right? How would you get those other gaps filled, which you need for your success in calculus? You're going to get something similar to that, but at different places. Let's see how we do that, right? So for pi/6 or pi/4, pi/3, can you find out the cotangent value of them? Everybody roll up your sleeves, okay? Do it. When you do these exercise, okay, when you do these exercise, you are reviewing from pre-algebra to trigonometry. So these are trigonometry concepts. But the reducing of these, the calculation, right? So cotangent pi/6 is a cosine pi/6 over sine pi/6. Cosine pi/6, and then you go where? Where do you go to? Okay, I'm going to bring the unit circle here. The unit circle is right here. So the angle is pi/6. Okay, so I'm going back here. You see, this is the place you always start. A pi/6. And I should not be using red because red is a forbidden, right? It's a forbidden one. Okay, so I'm going to draw the forbidden. Okay, the red terminal are forbidden for cosine. Are you guys follow me? So now I'm going to draw the terminal with the green. Pi/6, that's A. ARD. The reference angle is the same, which is pi/6. So what you do is that you're going to calculate the ratio of cotangent pi/6. So it's a D, ARD. Do you guys see that? ARD all day long. ARD all day long. If you keep doing that, one day you realize you are invincible. You're so good at doing ARD, any questions is no questions to you. Okay, and that's your shortcut. If you're asking for any shortcut, this ARD is a shortcut. All right, so you are going to do what? Cosine is the red number, sine is the blue number. So you're going to divide √3 over 2. You will see that as we go through this process, you will see a glimpse of something similar to what we did in for tangent. Okay, and then you reduce it, right? You multiply a 2 on both top and bottom. What part, right? So this is a trigonometry concept, ARD. But when you're doing this basic, math, that is pre-algebra. That's a pre-algebra. Okay? That's pre-algebra. Can you do it? So at the same time, we're reviewing pre-algebra. Do you follow me? So what does that equal to? √3. Okay. Some of you may get this done very quickly. Some of you may need a little more time. So that's how we're trying to take care of everybody. So go for it. Okay. So now we got a point. The input is pi over 6. The cotangent ratio is √3. And what are we going to do with this point? We're going to put this point where? Where are we going to put this point? We're going to put this point in the rectangular system. We're going to put this point in the rectangular system. Okay. So this time I'm not using a blank because everybody get a cotangent curve on their fingertips, right? So I'm going to put this point on the curve. You see that relationship, how we do that? Right? And this is going to be a red dot. Boom. That's the dot. That dot is this point. Right here. That's the journey. That's the journey from input to input output. Using unit circle to get to the curve. Because on this curve of cotangent, it only shows input as angles in the domain and output is the cotangent ratio. Consistent with the same way we did sine, cosine, tangent. Do you guys see that consistency? If anything, math, they need to be very consistent. And so you do this point by point. And special angles make it a little bit easier. Okay, so you don't have to punch in calculator all the time. I know you guys are pretty good at calculator, but now I want you guys to put it away. If you want to get a few more points on your calculus class, okay, if you want to get a few more points from this class or get you a few points in your calculus classes, you drop the calculator and you learn how to get used to these numbers, √3 over 2, √2 over 3, √2 over 2, things like that. Why? Why? Because all the math professors you are going to encounter in four-year schools, that's what they like to see. And you want to get points from them and do what they like. It's plain and simple, isn't it? Yes? Is that pretty simple? Yeah? Okay, so with that said and done, I want you guys to do that for 3 other points, or 2 other points. We haven't thought of 0 yet, right? Shall we do 0? Shall we do 0? What is a cotangent 0? Right, think about that. How about you do the other one? I did pi over 6, right? You're going to do, so what is the trajectory here? What is trajectory here, right? We have chosen terminal, right? From pi over 6, we'll get to pi over 4 and pi over 3, and we're getting closer and closer to pi over 2. Okay? We get to pi over 2. And we get over. So that's the trajectory, counterclockwise. So and then there's a forbidden place, right? Boom, we cannot touch it. We cannot touch it, right? On this place, we cannot choose 0. But we can get infinitely close to 0, right? So these are the situations that's similar to tangent situation. Okay, so you can only go very close to 0 and all the way here, but not touching pi. Because there's a forbidden. There's something that's forbidden there. Okay, forbidden. Forbidden. Not in domain. Okay, not in domain. So are you guys done with these calculations? Yeah? So by doing this, we are reviewing trigonometry all the way back to pre-algebra. All the way back to pre-algebra. Okay, so I'm going to give you a few more points. Pi over 2. Okay. When you're doing this, okay, 2 pi over 3, 3 pi over 4, right? Keep going. Are you guys doing it? Right, this one would be 5 pi over 4 over 6.
Professor, you mentioned not using calculator. Yes.
Don't use a calculator. Use ARD. Well, if you use it, I cannot stop you. But it's okay. Whatever. I recommend you not to use calculator. How about that? Right? America is a free country. You can do whatever you want. For your benefit. For your benefit. For to getting the points in your other classes, future classes. Yes, I recommend not to use a calculator. Thank you, Farouz. Right? Oh, cotangent, I'm sorry, I have a typo there. Cotangent pi over 4, what do you get? Just a red number divided by what? The red number divided by what? The red number divided by the blue number, right? Did you guys do this yesterday after class? I asked you guys to do it. If you did it, could you privately message me? But it's okay if you didn't do it. In the ideal world, you have done it, right?
So, Professor, this is the practice on unit circle, how to learn about the unit circle.
That's right.
Okay.
So, shall we do a breakout rooms?
I'm ready.
Okay.
I'm going to watch.
Let's have the breakout room available to you. So if you want, right? Go for it. Otherwise, you just do it here. You know, I want to comment on this thing that you must get involved with your paper pencil, right? We watch in NFL, we watch those football players, right? They're doing it. But don't forget, they get paid the big bucks. We are watching it. How much do we get paid? We're not getting paid, right? We don't get paid, do we? You have to pay them. Yes? The same thing is doing math. Well, I don't get paid much, but decent. You have to pay the school to get the degree, don't you? So now I got some message from Pronto. Let's see what that is. I accidentally did all the tables instead of just the sign. Oh, that's great. That's great. Okay, someone messaged me that he did the table. He did all the table. Great. How do you like it? I'm not going to mention who did it. Did you learn something? Did you learn a lot from this experience? Let me assure you, the reward is yet to come. Okay, it's benefiting now. Yeah, it's going to be benefiting in the future in your calculus class. Okay. They call delayed gratification. Delayed gratification. All right, but anyway, so this equals to 1, right? How about this guy? Equals √3/3. Yeah. How about cotangent pi over 2? Cotangent pi over 2 equals to cosine pi over 2. What is cosine pi over 2? Divided by sine pi over 2, right? Yes. What is sine pi over 2? Cosine pi over 2 is 0. So 0 divided by 1 is 0. Therefore, it's 0, right? So you got all these points. In the process, you've done these special angles many times. You no longer have to memorize any one of them. Right? So you keep doing this, doing the ARD way, okay, doing the ARD way, and soon enough, then you just do it naturally. You just do it naturally. That's what you want. That's what you want, right? So at pi over 2, cotangent is 0, right? And then you have 2 pi over 3, and and you have a cotangent 2 pi over 3. Now what do you get here? What do you get there? What do you get there? That's a terminal, right? That's a terminal. The terminal is here, right? You have your terminal. 2 pi over 3, measure from the 0, 2 pi over 3 is right here. So the red number divided by the positive by the blue number, what do you get?
-√3.
The red number divided by the blue number.
-√3/3.
Yep. You guys get it? You guys get it? Everyone you do is you have ARD reflected in your mind. Eventually it becomes very quickie. It's very quickie. Okay, so you're going to take that red number, which is -½ divided by the blue number √3/2. It becomes easier and easier yet. Okay, so you're going to get -√3/3, and you get these points, right? So 2 pi over 3, right? This is the arc length on the unit circle, and -√3/3. You see, that's how Rome is built, bit by bit, bit by bit. Okay, so cotangent, right? 3 pi over 4. 3 pi over 4. What's the cotangent of 3 pi over 4? You do the same thing. You do the same measurement, right? And it's 3 pi over 4. You end up over here. So this angle is 3 pi over 4. The reference angle is pi over 4. And the terminal, you have a negative, the red number, the blue number. The red number is a cosine 3 pi over 4. The blue number is sine 3 pi over 4. So that's how you get it. Are you guys with me? You need to have those thoughts reflected in your mind. You follow me? Okay, so this is enhancing ARD. So you get, you should get -1 here, right? And cotangent of 5 pi over 6. What are you going to do? What are you going to do? Right? You measure the angle from the standard position, counterclockwise, you ended up here. The point on the unit circle is a point chosen on the terminal side, the red number divided by the blue number. So I don't want to repeat myself too much because you're going to really get bored, but that's the process. That's the process for each one of them. Okay, so now you can, I'm going to leave in plot the points for you because I said I try to get this part passed quickly. Okay, we don't have so much time. We don't have so much time in class. Okay, otherwise something has to go. 5 pi over 6. Even this, 5 pi over 6 and comma -3. Okay, so that comes the interesting part. So all of these points, if you plot them, okay, it's going to give you a bunch of points over here. Okay, it's going to give you a bunch of points over here. Okay. Have you guys plotted? But the interesting part about this is that because we know there's a 2 forbidden terminal, right? I remember, people talk about, in some situations, people like to test the boundary. Mathematics want to test the boundary a lot. Okay, doing math, sometimes you test the boundary a lot, right? So we want to test the boundary. We know that we cannot be 0, but we want to get it closer and closer yet to 0. We want to see what happens to the ratio. Okay, in the other direction, we want to get closer and closer to pi to see what happens. You guys follow me? So you kind of want to tease the boundary, get it close to boundary, as close as possible. Okay, so we want to see, you will see this situation is done a lot in calculus. Okay, they don't ask you questions about those, continuous differential, perfect points. They're always asking you at those problem points. What happening at the problem points? Okay, what happened when when the angle is closer to pi What happens if approaching 0? They always ask you these kind of questions. Is that right, Farouz? Because the other points are boring. We already know. So what happens if, so this creates a dynamic process, right? You say, what if the terminal is getting closer and closer and, you know, getting closer and closer and closer to zero? What happens, right? And in the other direction, what happens if we get closer and closer and closer to zero? So with these questions in mind, guess what we do? Reflected on the table. First of all, this is undefined, isn't it? This is undefined, right? Because those are on the forbidden, right? That's the forbidden. And this is also what? Undefined. You guys follow me? And then what? Yes, it is undefined, but what if we get closer and closer to it? Right? What if we get a 0.01? Right? From 0.1 to 0.01. So we're getting closer and closer to zero. What happens? Or 0.01 and 0.01 in radian. Right? So what would be cotangent 0.001? Now you can use your calculator. Now we have to use a calculator. 2 zeros here. Right? These two inputs are not zeros, but they're getting closer and closer to zero. We want to observe the behavior of the ratio. Right? That's how they're created. And if you, I realize you guys like the degrees, right? So let's do the degrees. So this is supposed to be 1 degree, right? We're getting closer to zero. So this is going to be 2 degrees. Okay. So from 2 to 1, we're getting closer to zero, right? And if you like to do a 3, let's do it. 3 degree. Okay, so this is 1 degree. It doesn't matter use radian or what degree, but when we graphed it, when we plot the points, we have to convert it to radian. So we're going to take this opportunity to do the conversion, to radians. Okay, 2 degrees, and this is going to be 3. Right, so that's getting closer to zero from bigger than zero. Right? So observing this process, what do we want to observe eventually? What do we want to observe eventually? We want to observe when the angles approaches zero from larger than zero. Right? We're approaching zero. We know we cannot be zero, but from larger than zero. And then you say, do we observe from smaller than zero? Of course we do. That's your work. Okay, we can't do everything in class like this. You have to be just as inspired after we see what's been done in class. You do the other part. What if it's approaching zero from smaller than zero, right? To analyze that. And how about the pi? On the pi piece that we're going to say, oh, I'm going to approach pi from smaller than pi. This is smaller than pi, right? Smaller than pi. So the other thing we're going to observe after this is going to be that. So could you guys find these values for now? So you know our plan, right? So let's do it. Cotangent 1 degree. So you need to set your calculator to 1 degree. I'm going to turn this to Farouz. Farouz, do you have any instructions on how to use their calculator? You should just have a simple calculator if you want to do this. If you don't have a simple calculator, your computer might have some simple software for you to use. You don't need to buy an expensive calculator. No need. I'm expecting those numbers. there are going to be approximations, right? There are going to be approximations. What do we get? Yeah. What do we get? What do we get? Hmm? Are you guys there? Are you there? I'm so glad that someone did the work I assigned yesterday. Okay. And the rest of you didn't get time to do it, but it's never too late. It's never too late. Okay. I'm going to reply to that person. Huh. Okay. Nobody give me a number. Can you guys help me to find these values? I don't have a calculator. You're refusing to help me? You refuse to help me? Cotangent 2 degrees is 28. 28. Thank you. 28.626. Cotangent of 1 degree. That's okay. Let him do whatever he wants to. So what's the cotangent 3 degree? Cotangent 1 degree.
For cotangent 1, I got 57.28.
57.128.
Yeah.
Okay. So the number is getting larger and larger, right? As we're getting closer and closer to 0, the ratio is getting larger and larger, right? Do we see that? How about we try one more? How about we try one more? I give you a degree of 0.1 degree. It's even closer to 0, right? Are you guys with me? We want to observe the pattern. Cotangent 3 equals 1908. Thank you.
Cotangent 0.1 is 573.
573.73, right?
It's 572.957.
22.9-ish.
957.
957. Thank you. So what do you see? What do we want to see? We want to see the pattern and tendency, right? Because we'll never be able to do infinite number of numbers, right? There are infinite numbers closing and closer to 0. So we see that as x is getting, as the angles are getting closer and closer to 0, what happened to the ratio? The ratio gets larger and larger. That's what we want to see. Do we see that? Right? As the angles approaching 0 from larger than 0, look at that notation. That notation is beautiful, isn't it? You're going to deal with that every day for a couple of weeks. For weeks. You're going to deal with these kind of notations. I mean, this kind of notation. I'm not saying exactly going to be exactly like this. You're going to be dealing with these kind of notations every single day for weeks in calculus. If you don't understand that notation, what are you going to do? You're going to lose points left and right. I promise you. But if you understand the notation, you totally understand the notation, and you're going to get points left and right. I promise you. I promise you. It's a promise. Okay, so we see the tendency, we see the change, we see as the angles are getting closer and closer to zero, cotangent ratio is getting larger and larger. And how is that seen in the picture? How is that seen in the picture? Right here. Okay, you're gonna hear something similar. As the input getting closer and closer to zero, what happened to the output? The output is getting larger and larger and larger yet. As large as you wish. Are you guys with me? That's the dynamic process I'm talking about. And that's a dynamic process you're going to deal with in calculus class on daily basis. Okay, so how do we describe this dynamic process? Well, as the angle approaching zero, as close as possible, cotangent of the angles is going to approach positive infinity. That's the description, okay? When this happens, cotangent A approaches positive infinity, right? So let's look at the other side. Let's look at the other side. Closer to pi. We know at pi, cotangent is undefined, right? At zero, cotangent is this very similar, like a tangent, right? Tangent is between negative pi over 2 to pi over 2. Cotangent is between 0 to pi, and then there's another period from pi to 2 pi, 2 pi to 3, and so this periodic, right? Now, before we getting closer to pi, right? We know we cannot take the value of pi, but we can get closer and closer to it, right? So now, without further ado, I'm just going to give you some degrees. Okay, so but how about 89.9? No, sorry. It has to be smaller 180 degrees, right? So 179.9 degrees. How about that? Right? 179 degrees. So just do these cotangent, okay? 178 degrees. Okay, maybe 175 degrees. They're not special angle, but they all have a cotangent value. And you're gonna work these cotangent out. 175 degrees. Are you guys doing that? Do that. Do these groundwork. I promise you, you're gonna benefit. Okay, someone just told me that he did the work I assigned yesterday, and he said it's beneficial. It's beneficial. That's how your good grade is built. Okay, that's how your good grade is built. Okay, so now I'm sorry, Farouz, and I'm moving ahead to pi. Okay, so these numbers approaching pi. Okay, so eventually, because we want to observe as the angles approaching pi from smaller than pi, what is the behavior of a cotangent? What is the behavior of cotangent? You guys, could you guys give me those values? Put them on the, put them where? Put them on the chat. We're solving. We're trying to graph a cotangent, that's all. Well, we try to understand the graph of cotangent. Thank you, Farouz. I went ahead to do the, approaching pi situation, approaching zero situation. I trust your group got it, right?
We work on the unit circle, Professor, decoding it, all those values for the unit circle. And now we are back here. We are going to catch up with all these signs you are showing us.
Okay, great. So now we're approaching pi. I'm using the degrees, okay, which most of you like to use it, right? So what happens? What happens as we're getting closer and closer to pi, which is 180 degree? Yeah. What are we getting? Getting closer and closer to pi. It becomes negative. Excellent. Right? We have a negative values. What is this? Negative on 178 is negative 28.636. Keep going. We haven't talked about plotting the points yet. Okay, we haven't talked about plotting the points yet.
And cotangent of 179 is negative 57.289.
289. Thank you. Cotangent 179.9 degrees.
Cotangent 175 is negative 11.43.
All right, thank you. Oh, 572. I'm sorry. So, sorry. 179.9 degree is 572.957. Thank you. So what do we see? As the input getting closer and closer to pi over 2 from smaller than pi over 2, which is approaching pi, getting closer to pi from smaller than pi, what happened to the ratio? The ratio is getting smaller and smaller and smaller. Okay, approaching what? Approaching negative infinity. Approaching negative infinity. You can see that you can do these things totally on your calculator and you will see the pattern, right? Right, you just have to know where to look. You just have to know where to look.
Professor,
Now, yes.
I just see in the table the pattern between the cotangent 179 degrees and 179.9. The decimal point for the answer moves to the right 1 decimal places. Do you see that pattern?
Oh, the decimal point moved to the right. Yeah, the
Yes.
number is getting larger and larger.
So we don't need calculator for the furthermore, accuracy of 179.99999. It just
No.
goes toward the negative infinity, as you said.
Yeah, but I'm not going to do it in class. You guys
That's
can
right.
do it.
That's
You
right.
guys can do it after class, right? For the fun of it, right? You will see
Yes.
that pattern is going to continue, right?
That is a proof going toward negative infinity rapidly.
Right. It's not, yeah, it shows. I wouldn't say it's a proof because it proves, it's something different. You see it demonstrates the pattern, right?
Yes.
Increasing, decreasing, right? This is obviously a decreasing because your angle is getting larger and larger, but your ratio is getting smaller and smaller, right?
That's true. Yes.
So that's a decreasing function. That's a decreasing function on that piece, Okay, so then what? I promise you guys we're going to review about how to convert the degrees because you cannot plot a 0.1 degree on the curve. You cannot do that. You have to convert 0.1 degree to radian, okay, which is you have to multiply pi divided by 180 degrees. Okay, just remove the degrees because degree cancel. So you just have to multiply the degrees with pi over 180. That's going to give you the radian. Okay. So could you guys do that radian for me? Take a look. What is that radian? Okay, I assume this is a gap, right? So 1 degree multiply pi over 180. That will convert 1 degree to radian. That's 57.28. Okay, so this is review all the way back to what? Pre-algebra. 180. Okay. And then you have 2 degrees. 2 multiply that, and the output is 28,626. So once again, you cannot plot degree. You have to plot the radian in the picture. So how do you convert degree to radian? So this will be the exercise to review trigonometry for you. Okay, how to convert. Okay, so 3 degree in radian would be 3 multiplied pi over 180, and the output is 19.8. Does everybody follow me? Does everybody follow me? So can you do the calculation for yourself to see what is a radian? You can key in calculator. So this is reviewing from trigonometry all the way back to pre-algebra. Okay. You with me? Did you get those numbers? Did you get those numbers? That's the radian. You take that radian, you plot, you find the input, you draw that orange. Okay, that's the arc length. Okay, that's the arc length. You take that arc length, you straighten up like we used to do, and put it in the graph. Do you guys follow me? Yeah. For each one of those, and keep going. For these other degrees, right? You have 175 degrees. Convert that to radian. You're gonna multiply 100. You're gonna multiply 100 pi over 180. That's the radian value of 175 degrees. Okay, so that's the radian. Keep going. 178. Okay, 178. How to convert that to radian? You multiply pi over 180. And the output is a negative 28,636. You can understand why your professors in 4-year school doesn't want to deal with this, right? Right? It's much easier to deal with the special angles, right? But it's necessary to do this for you to understand the graph. Especially the graph is so easy to get. It's at your fingertips. And the end results, because they're so easy to get, we end up seeing nothing. We see the graph, but we see nothing. But this process is to help us see something. Okay? It's to help us see something. This is 179.9 degrees. Converted to radian. And their output, one is negative 57, And the other point is, for this reason, you know, we prefer radians. In calculus classes, you use radians only. You use radians only. Okay, you better get used to it now. Wonderful. Farouz got 0.1 degree converted to radian is 0.001745. So that will be the input. So that will be the input. So this number is going to be the input. It equals to 0.001745. So for 175 degree, and he's going to he converted to radian. That's going to be, that's a 3.054 radian. Okay, thank you for doing this. I want you guys to write it down because we need to move forward. Okay, we need to move forward. Okay, I might give you a quiz. I might give you a quiz converting degrees to radian. Okay, we cannot spend time like this so generously here. You guys got it, right? You just have to do the calculation, review your basic algebra, basic arithmetic. All right, so we understand from this curve, what have we observed? What have we observed? Let's reiterate what we have observed. As the angle approaches zero from larger than zero, the output is getting higher and higher to positive infinity as large as you want. As the angle approaching pi, getting closer and closer to pi, it cannot equals to pi. The output is approaching what? Negative infinity. So this observation in mathematics, we have just summarized in the table, right? We have summarized in the table, right? And what is it? As a, well, let's do the zero first. When the angle approaching zero never is zero, from larger than zero, cotangent approaches positive infinity. When angles approaching pi, not equals, never equals to pi, but approach to pi from smaller than pi to infinity, to from smaller than pi, infinitely close to pi, from smaller than pi, cotangent approaches negative infinity. And that is reflected in that picture. That's reflected to the picture, right? So there's a vertical asymptote. There's a vertical asymptote. What is that vertical asymptote? That vertical asymptote is going to be like this. Okay, so I'm going to use a red line to indicating that broken line. That's, it doesn't get close to. Get it as close as possible, but never touched it. How about on the other side? On the other side, we're just talking about one piece of the curve of cotangent, okay? Many points is missing that I didn't didn't do it. And you guys are expected to do. And this other one would be the y-axis, right? So each rule has its own different nature, right? Each rule has its own different nature. I'm going to make it a little thicker so you see the other vertical asymptote. So you're going to have lots of vertical asymptote that will make the complete curve. And what are those vertical asymptotes? What are those vertical asymptotes? They're k pi. Okay, they're k pi. So let's summarize. Tangent, cotangent now, right? Are we ready? Are we ready?
Ready.
All right. Right, this piece, right? So when A is approaching 0 from larger than 0, cotangent approaches what? Positive infinity. Okay? When the angle approaches pi from smaller than pi, you see how natural the symbol is introduced. That's what I want you, that's why I introduced these symbols to you earlier. You see, it comes naturally, isn't it? If it's not today, tomorrow it look more natural. Cotangent A. I taught calculus classes, when I taught calculus classes, in a lot of cases, the students struggle with these notation. They lose point along the way. All they miss is the plus sign, minus sign that should be on the shoulder. And they missed it. So they lose 1 point here, 1 point there, 1 point there. Just look, they lose 1 point everywhere. And they all add up. They all add up. Okay? So that's why I resolve, if I teach pre-calculus, I will try to introduce this earlier whenever it's appropriate. Okay, so y-intercept, x-intercept. We already talked about there's none because 0 is not in the domain. How about x-intercept? How about x-intercept for tangent and cotangent? How about x-intercepts? I think we talk about x-intercept, right? We talk about x-intercept for tangent. What's the x-intercept for tangent?
Wasn't the x-intercept for tangent k pi 0?
That's right. We did that, right? I just didn't put in a table. K pi. Okay, so go back to view the lectures before, if you have hard time with it. I feel we have spent a lot of time here. And if you truly want to learn, right, you have got it. You've got it. So how about the x-intercept for cotangent? What are those x-intercepts? What are they? What are those points? What are those points? It's a little difficult to identify from the picture itself, right? Because they're not precisely 1, 2, 3, right? They're not precisely 1, 2, 3. So where do we go to? We will go back to the facts that to find the x-intercept, what is it? What is it? The input is angle and cotangent function. So this is the old story, right? Nothing new to you. The only thing is that this is a new function, and to find the x-intercept, that the output is 0. The output is 0. So you're going to identify all the possible values in the domain of cotangent that produce 0 output. So which number produce 0 output? Then you look for those numbers that red divided by blue give you 0, right? Yes, red divided by blue, right? Cosine divided by sine, it should give you 0. So what terminal have we found? And this is one terminal, and this is the other terminal, right? Yes. So what are the angles we can find? Angle measurement, ARD. This is DRA, from D to A, yes? So your angle would be what? Pi over 2, 3 pi over 2, negative pi over 2. That will give you the x-intercept, right? And you can just keep going. What did you find? odd number multiples of pi over 2, aren't they? Did we see this for the first time? Absolutely not. We've seen this in the other settings. In the situation, one of the x-intercept for cotangent A is pi over 2. Absolutely right, Alexa. But there are more. There are infinite number. There are infinite number, many of them. So what are they? That will be odd number multiples of pi over 2. 0. Those are the x-intercepts. And k is any integer. Okay, so we're going to put that in the table for x-intercepts. By this time, we're done with tangent and cotangent. And you should look ahead to look at secant and cosecant. In that process, you're going to see, okay, from that relationship, right? Secant has something to do with, excuse me, it's reciprocal of cosine, right? Excuse me, cosecant is reciprocal of sine. So that's why we're not going to do it in class. Let's leave it for you. Will I be quizzing you on that? Absolutely, I have the freedom to quiz you on that. Okay, I do. And I will probably use it. I will probably use it, okay? And hopefully this will make you just work beyond what's being covered in class, okay? So you need to do whatever is in the class and more. That's usually what your professor expected of you when you are doing academics. Okay, so if you want to get that degree, you just have to do this. I figured that out a long time ago. Your teacher asked you to do 1, 2, 3, you probably should do 4, 5, 6, 7, 8, 9. When I saw my kids only do the homework that assigned to them, I was astonished, right? The teacher only assigned them to like the odd numbers. Hey, you guys need to do the even number too. Guess what? They don't listen to me. You don't listen to me, right? Guess what? The test question may come from the even number. Okay, so I'm just asking you to just do a little bit more than you're being asked for, okay? But anyway, so that's for tangent, cotangent, okay? So all 6 functions will be used. So you guys should do the summary because I have given you the bits and pieces of the summary. Then you say, how about sine, cosine? For sine, cosine, we didn't do this, right? Did we do this as for sine, cosine? No, we didn't. Why? What happens x approaching when the angle approaches negative infinity, positive infinity? Well, sine is always wiggling between up and down, up and down, up and down. So they don't approach any particular number. In fact, when x approaching infinity, sine doesn't approach anything. Cosine the same. So cosine, sine don't have these properties. They don't have these things, right? If you recall what we did for sine and cosine, right? We have a summary table, but we definitely didn't have these. Why? Because they don't have it. They don't have it. Okay, they don't have it. All right. So now, without further ado, do you guys have any questions?
So, Professor, the sine and cosine are also, we can say that they're continuous function.
They're continuous functions, yeah.
Thank you.
Yes. Okay, you're going to learn that concept in a more concise context. In even all the trig functions are continuous in their domain. It's just in the extreme case. Okay, this is talking about the limit. The first concept in calculus, that's what you have. Okay.
Thank you, Professor.
But anyway, The other thing I like to address in this class, we have addressed some deriving. We have addressed some deriving. And I have given you the homework, and I know some of you haven't get started on that. This is related to trig 17 and trig 18. Okay, the lots of deriving exercises for you. Okay, but for those of you who have taken trigonometry, that's great. You know, you guys just refreshing. But we also have some people who have never taken trigonometry. I will do my best, try to take care of you. But in terms of this content, I already put that in the homework and sent it to you from inbox and the pronto. I pointed out there's certain materials that I have done before. I put those recordings. Okay, I put those recordings here in the module. Okay. In this piece, these are the recordings I have done with my former classes, done it multiple times, and these are the recordings I think can be reused. What it does is that if you try to do trig 17, trig 18, we won't have too much time to do them in class, but they're useful for you. So what I did is I have this trig formula diagram. Okay, trig formula diagram. This is the trig formula diagram. And I personally created this. Okay. You can use it as a formula sheet. Whenever you need something, you go to it. But I also recommend just you guys to watch the video as how they're being derived and derive them yourself. If you derive them yourself, okay, many of my students in the past, when I derived them these with them, and they carry that, they actually, some of these students actually did it. Okay, I'm not saying every one of them doing it, I wish, but if you do it by your own hands, they commit, you know, following my examples, you do the whole thing yourself. Oh boy, your benefit in that is going to be infinite. It's going to be infinite. It will give you so much intuition, okay? And you will never have to memorize a single trig formula because you can derive them all by yourself. That's a tremendous freedom. That's a tremendous freedom. Okay, so by putting in some hard work, you get to enjoy that freedom for semesters to come. Think about that. Okay, think about doing it. So this diagram, what's in this diagram? This diagram, start from here. Start from this formula. Everything can be derived from here. Okay, so I gave you the flow chart, right? How to get from here to there, from here to there, and over there. So all these arrows tells you how to get to your destination. Okay, product to sum difference, difference to product, right? A product to sum and difference, and you know, difference to sum and product, a difference to products, right? Which is a factoring. Factoring is an important techniques. The double angle, which you need those formula, and the half angle. Okay. I will do this piece with my other class tomorrow, and I will have a recording for it, and I will make them available to you again. But they're similar to what's already available. No matter how many times you watch it, it doesn't beat the one time you do it. Doesn't beat the one time you do it. Okay. So of course I will be talking about if this formula is true. Okay. This formula is true. So keep going, right? So this is a chart. This is a chart. And my recording, okay, my recording in these recording, tells you how they're derived. How they're derived. So you just watch them, there are YouTube videos, or YouTube recording, have your paper pencil, do it next to it, and pause and stop whenever you need it. And in time, oh my God, I personally benefited from it a lot. But no one did the diagram for me. I did it, you know, I did it. So that's my gift to you. I trust that you're gonna need that diagram in calculus classes. Okay, but if you do it yourself, you can just dump that in the trash. You don't need it. It's all in your head and no one can take it away from you. It's all in your head. It's a great training, okay? So when it's possible, I do this to every semester of my students in Math 1 pre-calculus, but I put it here because I want some of you who has the energy and time and a drive to get started earlier, to do it earlier rather than later. Okay, it's your study, it's your degree, it's your life, your career, right? So make what you want. Make what you want. All the resources are here. All the resources are here. Okay, so you can see that these materials, right, it's right here. They're all here. I wrote them up. I wrote these up. I wrote them. Okay, some of the recordings are from prior semesters, but I think it's valuable to show it to you. So I did. And we go week by week. Yes, you do have a lot of material, but if you want to be successful in your calculus classes, plural, you have to make a tremendous effort this semester. Tremendous. Okay, and after Christmas, next day you start reviewing once again, even though I'm not there to watch you. There's so much to do, and there's only so much we can do in classes, right? So all the materials are here. All the materials are here. We're in week 5, right? So now I'm kind of not taking these down because in the past semester I took them, in the past few weeks I took them down. Okay, so these are the old lectures. These are the old lectures. I often approach, these topics actually from different angle. So my lectures just from semester to semester are not always the same. Okay, don't think, oh, I'm always doing the same thing over and over again. No, I don't. Because sometimes I emphasize this angle, right? Sometimes I emphasize this angle. So you will learn, I promise you, I think you're gonna learn something from my past lectures. So for that reason, I did not put them away. I put away the first week's all the stuff. But ever since the second week, and I stopped putting them away because I wish them to be helpful for you. Okay, I wish them to be helpful for you. If you want to just see a slightly different way of doing things, and it just give you some added benefit. All right, so without further ado, do you have any other questions? Do you have any other questions? You cannot satisfy yourself with only doing what I did in class. You have to do more because this notes, we cannot finish in the notes. I knew it. We cannot. But everything in the notes is going to be beneficial for you. Okay. Okay, so your question, I know you might feel overwhelmed. Natural. Some of you may have to take it again. Okay. Do not be discouraged because you are taking 5 classes in one. Do not be discouraged. Do not be afraid. You just have to be patient with yourself. Okay, I think loving ourselves is partly include be patient with ourselves. Okay, and I hope I have shown you the way to do, and I will maintain that theme of function. I still maintain that theme of function. I think this will do. This will do. All right. So anyway, so let's go back. With the remainder of the time, I want to get you started, right? So derive. Why I want you to get started to derive? Because we won't have much time deriving in this class. But do you need to derive? Yes, you do. You need a lot of trig deriving. You need that in Calc 1, Calc 2. At least. Okay. For those of you who have never taken trigonometry, you are at a disadvantage. You must start deriving since yesterday. And I have provided you with the exercise, okay? So for the remaining time, which you don't have a whole lot of remaining time, I want you guys to work on secant, cosecant. Okay, so I'm going to create that table for you as a okay, secant, cosecant. Oops, sorry. I want to speed up and then I ended up slowing down, right? Secant, cosecant, right? The rule, right, which is 1 over cosine. I'm not going to do it in class because we don't have time. You must do it. You must do it. Okay. From the rule to graph. Okay. From the rule, right? The function as a rule, which you know the drill, right? I always type it that way. And this is a new rule. Right. And outside, you know, is secant A, right? Just for example, and then you're gonna work with the domain. Range. We already have worked out the domain, and range is something else. Actually, your quiz is asking for that. Okay, your quiz is asking for that. The domain is we already know. Okay, I already given to you, you know, the other day. Range you need to figure out. Where do you figure out from? Definition. Okay. If you understood my lecture in the past, then you would say, oh, it's just, you know, R over Y, R over X, right? And that relationship and intercepts. Okay, X intercept, Y intercepts. Intercept, right? So these are the things you need to work on. Y-intercept, right? Y-intercepts. These sort of things. Do we have those other tendency like the limit notation? Yes. For these functions, you do. For these functions, you do. When A approaches certain things, and when A approaching certain things, these are to be discovered. These are to be discovered. No, I don't believe anybody taught trigonometry will ever cover this. Even I won't cover this unless it's highly demanded. No time, there's no time. However, it is expected of you. It is expected of you. Okay, I might do some recordings. This is outside the, you know, outside our teaching time for you. Okay, I'm thinking about that. But the analysis, the technique of analysis, you already have them. You already have them. Okay, so these are the last minute, give you some guideline as to what to do. So you have to discover for secant, cosecant. It will be great drill for you, and it will better prepare you for calculus classes. Okay, tomorrow, I hope tomorrow I will get started on the inverse functions, trig inverse functions. Okay, why trig inverse functions, right? That's another important topics. Okay, we have much to discover, and that's what I will do with your class. With my other class, which is 2 hours, then I will do some, other stuff. I will do some other stuff. But whatever recording I get from there, I will share that with you. I'll share that with you, especially about the unit circles and stuff. Okay. Because these two classes, I kind of treat them slightly differently according to your specific needs. I hope I can be helpful to you in those ways. So once again, I'm looking forward to seeing you tomorrow, and keep up with your hard work. And I assure you that the reward will come in time. The reward will come in time. And yeah, it's not easy. I know it's not easy, but if you have any question, so please don't hesitate to reach out to me. Okay, you never bother me. I'll get to your question as soon as I can.
Professor, they can find me today and tomorrow, 3 to 6 p.m. Math Study Center.
Thank you.
You're welcome.
Appreciate you, Farouz, really do. And I'll see you guys tomorrow.
Thank you, Professor. See you tomorrow.
Of course.
Thank you, Professor.
Thank you. Great job. Great job.
Thanks for the lecture, Professor.
Of course, anytime. Great job. Great job. Okay, keep at it. You will get it. You will get it.